So first up is from Malaysia. We will have Dr. Hing Wah. He is the head of the Center for Semiconductor and Thin Film Research of MIMOS, which is the Malaysian Institute of Microelectronic Systems. Dr. Lee is a technology expert. He's an expert in semiconductor, advanced materials, advanced packaging, printed electronics, nanotechnology, graphite, and nano characterization. He's also a senior member of the IEEE and the chairman of the National Mirror Committee on Nanotechnology for Electrotechnical Products and Systems for the International Electrotechnical Commission. Dr. Lee, we look forward to your presentation. You have 10 minutes. Thank you, Dr. Lee.
Okay, thank you, Andrew. First of all, good evening to Your Excellency, Eric Cantella, Ambassador of Brazil to Malaysia, Your Honorable YB Liu Chin Tong, Deputy Minister of Investment, Trade and Industry of Malaysia, Your Honorable YB Dato Sri Wong, President of MSIA, esteemed panelists, moderator, experts, and all participants. So I would like to apologize on behalf of Dr. Iskandar, who is unable to attend due to unforeseen circumstances. Nevertheless, I will try to convey his message during this session. So I'm going to start off our presentation on MIMOS aspiration to drive the R&D in terms of high-value semiconductor technology research and innovation. To kick off, I'm going to give a brief introduction of MIMOS. So MIMOS is basically a strategic agency under the Ministry of Science, Technology and Innovation. And our vision is to be a frontier applied research center in E&E. And our mission is to pioneer innovative and technology development towards creating a local industry that is globally competitive. So we have around 600 staff in MIMOS with 200 strong researchers in MIMOS. And we have already generated more than 1,000 intellectual properties in the areas of ICT, microelectronics, and also semiconductors. So we have a lot of laboratories in MIMOS, but for the sake of today's session, I'm going to focus more on the semiconductor laboratories. So we have two wafer fabrication laboratories facilities in MIMOS. The first laboratory is called Fab 1, where it houses a lot of those R&D activity in terms of those novel new material synthesis, process technology, and device development. The second Fab 2 is basically the small-scale pilot production lab facilities, and we have capability in terms of the node size from 0.5 to 200 nanometers. So we don't have the capability to go up to smaller scale node, but we are going to plan to leverage on whatever node size that we have to pursue on the next generation semiconductor development in terms of wide bandgap semiconductor. Apart from the wafer fabrication, we also have one of the best equipped failure and material analysis laboratories in Malaysia. So this laboratory is able to support non-destructive and electrical analysis, physical analysis, and up to material analysis. And all our laboratories in terms of semiconductor facilities comply to the international standards compliance. So as you can see, so we have capabilities to drive R&D projects in cross-cutting domain from the design, wafer fabrication, assembly, test, and packaging up to electronics module and subsystem development. So a lot of our R&D projects are in collaboration with industry partners with the participation of a lot of universities and academic institutions. Apart from that, we also provide a lot of services in terms of technical and scientific services, and also technical talents development to the industry as well. So all our R&D projects are aligned to the national aspiration, which is the New Industrial Master Plan 2030 and also the E&E Technology Development Roadmap. So moving forward, we would like to embrace the philosophy that we want to push a lot of our front-end R&D activities, and the front-end activities that we foresee includes design, wafer fabrication, and also advanced packaging, because we foresee that in the future, in terms of design, for examples, we are not limited to IC design only, because we want to also embrace the philosophy of taking simulation up to the next level in terms of the wafer process fabrication and also packaging and system level types of simulation. And this is also, there's recently an article from Semi Engineering mentioning that everyone's a system engineer with heterogeneous integration, only published 2nd October 2023, which support these types of philosophy. So moving forward, these are the three main sectors or areas that we want to embrace on in terms of our R&D focus. The first one is basically on the wide bandgap semiconductors, and this is, as mentioned earlier, aligned with whatever wafer fabrication capability that we have at present. It doesn't need a very high, a small node size, and 200 nanometer is able to support the development in this area. And obviously, we want to also support our local OSAS industry to move into the advanced packaging development so that they can move up the value chain and also support our automated test equipment in terms of the electronic modules and system development. At the same time, we are going to establish a semiconductor research consortium. So this is where we are going to be the central facilities that is going to be accessible to all national semiconductors research activities in the academia and also research institute. So this will allow us to synergize all our efforts to focus on our national priority areas and to avoid duplication. So, and moving forward, there are some partnership activities that I foresee both Brazil and Malaysia can look forward to partners on. So we have a lot of inspiration to drive towards to target towards the net zero 2050. And one of the main areas of activities that we want to embrace on is on the deployment of solar. But in Malaysia, you'll be able to see that a lot of those large-scale solar farm deployment are focusing a lot of in the integration, installation, and services activities. So a lot of the other electronics components that are housed that involved in this deployment are basically imported from overseas. So this takes up around 40 to 50% of the overall cost. So if we leverage on our capability in terms of the electronics manufacturing, and we can develop our own balance of systems like electronic modules and subsystems, and we can see that we can capture around 1 to 2 billion of investment or market year annually. And some might argue that this might be a small portion, but if we look at in Brazil, you already hit a 30 gigawatt milestone in terms of solar deployment. So imagine if you at the Brazil can also develop all this balance of system locally in Brazil in partnership with Malaysian counterparts. So I think we can capture a bigger market in the future. Similarly, so this is for the electric vehicle sector. So a lot of those electrical modules and subsystems can also be developed locally in partnership with Brazil. So Brazil also has a large domestic market in terms of the EV moving forward. So this is some area that we can look to partner on. So as a summary, now we already have a very good state and government roles in orchestrating an effective policy implementation through the NIMP 2030 E&E Roadmap Technology Development 2021 to 2023. And now it already has published a lot of technology focus and alignment for the nation in terms of IC design, fabrication, advanced packaging, and ATE, which is to support our existing stronghold in terms of the OSATs and also ATE to move up the value chain. And subsequently, we can also look to enhance and develop more in terms of electronic modules and subsystems to support the ever-emerging electrification and also renewable energy segment. And MIMOS is going to establish a central national shared facility to our consortium effort. So we hope that Brazil will have some kind of similar effort that we can work together on. And obviously, we will collaborate and partners together to leverage on our existing capabilities and market access for future technology development. So we're going to embrace the whole of nation approach moving forward. Okay, that's all for my presentation today. Thank you very much.